All right, let's take a quick look at the base of DJ Rex here. You can see I've got the club print file, and inside of it I mounted a ring of plywood. And in the center of that, I've got this 3D printed mount point for my rotation system. One thing you can see is the mount point drops down. I tried to lower the center frame as close to the floor as I could, so there's not a lot of space inside Rex's base, so I wanted to maximize available room. The Lazy Susan will mount to the bottom of this printed ring. You can see over here I've got a fuse panel. Over here we have a port that goes out to the back. He runs off of AC power. He's not mobile, he's not portable, so there's really no reason to deal with batteries, just plug him into the wall. I've got a higher powered step-down converter to deal with the big 60 kilogram servo. And then I've got a bunch of other adjustable step-down converters for the various servos throughout the droid. I tried to keep one servo per step-down controller just to minimize the workload and give myself some sort of fault-tolerant zones. Over here, I've got a Pololu Maestro servo controller. Not familiar with those. It's a completely standalone device, so there's no Arduino or anything. You just load the code on it and it just runs. This Rex is not remote controlled. He's fully animatronics. You just plug him in and turn him on. So this is one of the Tambi Lazy Susans that are recommended in the build files. And what I've done is I have modeled and printed a chassis that will control the head lift and the head rotation. This socket here is where the servo for head rotation will go. You can see there's some 3mm heat set inserts. That's how the servo is going to mount. Over here, got a big 60 kilogram servo for the head lift. It's already in position, but where it's screwed in at the bottom, there are a couple more of those heat inserts and even more heat set inserts. You'll notice a trend. I really like heat set inserts. And also, despite being located in the United States, I do everything in metric, so just be prepared. Over here, we have a slot for some 2020 aluminum extrusion. This is where the linear rail for the up and down head motion is going to go. Next up, we have the gear that's going to lift the head. This is 3D printed. It is done at 75% infill, so it's essentially solid. This side looks a little bit funky because of the raft. When I'm printing gears, I always like to do a raft just to avoid any elephant foot at the bottom of the build plate. As much as I might like to say my printers are well tuned, I always get a little bit, and on gears that really kind of matters. This socket is modeled based on one of the servo discs that comes with the 60 kilogram servo that I bought. I've ordered some other ones to see if they fit, just out of curiosity, but just so you know, this is specifically modeled to the hardware that I bought. And here's the servo disc that I'd mentioned. I don't really like using non-metal servo horns, servo discs, whatever you want to call them, but this is what I got. I ordered some metal ones from like Banggood or AliExpress or something like that that are coming, so I'll play around with swapping that out. But overall, this is pretty thick, it's pretty chunky, 8 anchor points. I don't really imagine I'm gonna have any failure. It's definitely gonna be stronger than my 3D printed parts, so I'm probably stressing for nothing, but just wanted to mention that. And here's the lift gear with everything fully connected, lots of screws. When you're assembling it, you want to make sure that the head of the screw is on the outside and the nuts are on the inside, mainly because it takes a lot of pressure to push it onto the servo, and you don't want to be pushing on the ends of the screws. All right, so this little piece here is the cap for this big lift gear. So the idea is this pops on here, screws down, screws in the front, secures the top of the servo, leaves room for the cord, and makes everything nice and clean looking. Big servo is now fully screwed in. It's nice and secure, not going anywhere. 60 kilogram servo is pretty powerful, so really wanted to make sure that there's a big beefy mount point for it. All right, linear rail. So I had a bunch of this left over from various 3D printer upgrades. This is great hardware and not all that expensive, so highly recommend it. Basically, you have this rail, this little slider block, goes up and down nice and smoothly. It's got almost no play at all to it, so it's a nice, consistent, even motion. And it even has a cool noise for a robot. So what I have here is that will mount in this space, and that's the track the head will ride up and down on. If you've never worked with 2020 extrusion before, use these little T-nuts, as you see here, and when you tighten up the screw, the nut will turn horizontal like that and fit into the grooves in the extrusion and clamp it in tight. You see I've got these little red bumpers at the top and bottom of the rail. That is to prevent the slider from going over the edge. The sliders have all these teeny tiny little ball bearings in them, and they fall out if you even look at them funny. So that's why you keep those bumpers on the rail. Otherwise you'll lose bearings everywhere and you won't slide anymore. This is the unit that the neck is going to mount into, and it's going to take the neck up and down. It's 3 pieces. First, you get this little clamp. That's just to secure the pipe, make sure that it doesn't move around unexpectedly. We've got the main chassis. This here is going to mount to that rail we were just looking at. And then over here you have the gear teeth. This is modeled as a separate piece, both for strength, because we really want the gear teeth to face this way in the print bed, and also serviceability, because eventually those teeth will grind down. This way you just pop out a couple of screws, swap in a new gear plate, and you're back up and running. And final assembly here. I'm moving really slow because my servo tester doesn't actually technically have enough power to drive this big servo. But if I go real slow, it'll work. If I try to go any faster, it just kind of skips and stutters and stalls out. But you can see the movement is nice and smooth, go up and down really well, and once we have enough power coming to the servo, it'll go pretty fast too. Alright, here's the next servo. Now you see I've got this little contraption that it's mounted to. This is trying to keep in mind that servicing this thing is not easy. So you can open up a little bit of the bottom by moving the panels aside, but it doesn't give you a lot of room to work. So I wanted to make sure that this servo was easily replaceable with sort of top-down access only. So what I did was the servo mounts into this frame, and then this frame mounts into the base. So that way, if I needed to take the servo out, I could take these screws out, remove this entire unit, put a new servo in, and then put this unit back in place. I like to make sure that the servo wires are secured so you don't accidentally get a wire pulling out or getting caught in a gear or anything. Your positioning may vary. It happens that I have my servo controller board oriented over here-ish, which is why I secured it in this direction. These are just little self-adhesive zip tie mounts. I use a ton of those and a ton of zip ties. It's unfortunate that you have to cut the zip ties back out. I could spring for more expensive zip ties, but I just go with cheap bulk bags and cut them when I need to move stuff. Now if we look at the underside here, first you can see a bunch of random holes that I cut for various purposes, then decided I didn't need, so plywood's kind of a mess. You can also see that I can't really cut a circle correctly to save my life, but I wasn't trying very hard since I had a printed ring to go into it. So this plywood ring is glued and screwed into the plastic frame, so it's probably not ever going anywhere. And you can see more of my favorite friends, the heat set insert. Oh, and while we're under here, I didn't talk about this gear. So this inside gear segment is what's going to make the head turn once everything's installed. Alright, the base unit is installed. You can see it turns freely. I also like to point out, I try really hard not to have any of these servos directly connected to anything. Again, because I want to try to make this as easy to service as possible. So you can see I've used these little servo extensions, and I have them labeled so I know what's what, because there's a lot of cables going on in here. So what I'll do is I will connect the neck rotation and the head lift to their extension cables, and then we'll power this up and see if it works. As we start reassembling Rex, cable management becomes kind of challenging. So what I've done is I have mounted some more of these zip tie anchors to the insides of the pedestal. Since it's not a flat surface, the self-adhesive pads don't really hold very well, but I just smucked a bunch of hot glue on the back of it and pressed them into place, and now they're on there pretty securely. So next up, I will reattach these screws to secure the base back into position, and then I will zip tie these cables along. Let's talk about servo extension cables. So I really wanted to avoid custom cables anywhere that I could. I didn't want to be cutting and soldering and splicing. So I'm using servo extension cables to get my wires up to where I need to go. But all these little junctions are potential points of failure. So before you close up the droid, if you go this route, I highly recommend you tape these connections. I like to use Kapton tape. It's nice and clean looking, and it doesn't seem to degrade over time. It doesn't leave gross tacky residue. So I'm going to go tape those. I'll be right back. Alright, here are all my cables. I've got the Kapton tape to keep the servo extension cables from coming loose. Everything is bundled up and zip tied to the side. So this layer of the cake is done, and we're ready to move up a tier. Okay, on this layer, you can see that I very brute force modified one of the print files that's included in the club file pack. I needed my servo and gear to fit in here. I needed the gear to be a certain size in order to fit with the spacing of the ring, and that meant I had to clip off a section of this printed part here. I know I could have modeled a new file, altered the club files, but sometimes it's easier to just use a Dremel. So then I also have this inside gear piece, which mounts onto the Lazy Susan and fits in the gap that was already present in the club file. This way, when the servo turns, it moves the ring and moves the arm. So it was a relatively minimal mod, and I'm sure some enterprising person out there could go ahead and update the club file to fit this if they felt inclined. Now, next part here is going to be the cabling. So I've got to connect this servo, and I have to connect it to the right one of these, which is why we labeled all of our wires. So lower ring. So this is where I hook up the servo. I've got a lot of excess cables, so I have to bundle them and sort of tuck them away so they don't get caught up in anything. What you really don't want is a wire ending up in there and getting run through between the servo and the gear. That won't be good for anybody. All right, cables are bundled up. Everything's zip tied over here. You know, as I'm going, I know that these zip ties are just going to be a pain in my butt the next time I have to take it apart, but I'm not putting them in very tight, so they're easy to remove, and I just feel better knowing that the wires can't bounce around, move, shift, anything like that while it's running. So for the next part of the stack, I'm using this spacer ring from the club files. I don't even know if this is what it was intended for, but I find it's helpful to give a little extra clearance so that the Lazy Susan doesn't bind up when things are spinning. Okay, so this layer has a lot going on. Lots to talk about in here. So we've got an Arduino Nano, which is tasked with the LEDs. We have this kind of chaotic mess of wiring, which represents the 18 individual LEDs and then the 9 addressable LEDs that make up the front panel display. There's also this pair of wires coming out for the eyes, which will connect up to the head in a second. Connecting this ring to the lower one, instead of a Lazy Susan, is a custom piece I modeled. Reason being, first, this section doesn't have to rotate. Second, I wanted to have an upper level support for the head. So I found with the head rod mounted just below, it was a little bit wobbly. So using a smaller Lazy Susan and another linear rail like I had in the bottom, I can create a brace that will keep the head stable, but still lets it rotate and go up and down freely. And then over here, we have all of our extension cables, and then we get up into this little bit of fun. So for the head, I used an RJ45 patch cable to connect it, since the head I tend to take on and off pretty regularly, and I just wanted a single wire going up there. Where I failed to think things through very well, you can see I've got nice disconnects for the servos, but for the LED eyes, I didn't put any kind of disconnect in. Instead, I just have those screwed into the terminals. It's not pretty, but I will go back and fix it at some point. So for now, you get to see my sins. And also, again, we have cables here that could come apart, so I'm going to put some Kapton tape on those to hold them in. I recommend turning it on and checking all of your wiring as you're going, because otherwise you have to disassemble all this stuff again to get back at a problem. So at this stage, you see my lights are good, my lower arm is good, and down here, if we check, we can see the head is going up and down and left and right. There's just no head there for it to be turning yet. On to the top ring. So here's where we start connecting the servos for the hero arm, and we start feeding things up to the neck. Here's the upper ring servo. The way that I approached the design for this is you can actually see I've got a little bracket in here which fits in between the Lazy Susan and the printed ring under it, and screws together when you screw the Lazy Susan to the printed ring. That holds the servo in place, and then I've got this inside gear here which handles the rotation. So pretty simple system, doesn't require any modifications to the stock parts. Another verification round, we can see that the hero arm is turning its wrist, it's moving its elbow, the top ring is rotating, lower arm is still moving correctly, lights are still moving correctly, so I haven't broken anything, and that arm was just removed because it was in the way. Look inside, you can see the servo just moving that ring around, going basically right up to the limit of its motion. These are 270-degree servos, so they have a little bit better than 180 rotation. So try to get as much movement in there as I can. And then in this arm, I got a servo buried down in the elbow. This is one of the only parts that I modified pretty extensively. I remodeled the main bulk of the hero arm. There's a small servo inside the yellow part at the wrist here that's turning the hand. Then there's a bigger one down there in the elbow. I've concealed it pretty well, so you really can't see it externally. I still used the same side pieces. I still used all of this from the original. I still used the fingers, but the hand, the wrist, and the bulk of the arm I made a new version of. So I'm using this for the two servos in the head, the neck tilt and the visor lift, and for the LEDs for the eyes. Now, you see how I've got this wire sort of wrapped around and taped. That's because you really don't want flex at these points here. You know, I've seen various arguments for or against tinning the wires before you put them in there. I'm going to leave that as an exercise to the builder. But what I do know is if you bend back and forth at that point, they're going to snap real fast. So, to relieve stress on them, I folded them over and taped them to the back of the connector. It's very important to remember the tab where the RJ45 cable connects in. You want to make sure that's clear so you can get the cable on and off. Okay, that seems like a pretty decent connection. I can access the RJ45 port easily, the cables aren't going to go flying around anywhere, and nothing should be moving regularly, so there shouldn't be any stress on the screw terminal connections. Pro tip, put the neck rod in before you put all the layers on, because it's real hard reaching those tightening screws once it's in. Now in this case, my neck rod is probably still a little bit too tall. I haven't cut it down yet because I wanted to see the final assembly, but I'm likely going to have to take an inch or two off. So I've got this assembly that links up to the visor and to the neck. You really can't see a lot of it just because it's already installed and there's no easy way to get it back out again. But what we do have over here is the other end of that RJ45 link. The cable is pointed this way so that it sort of flows nicely into the neck. And then the plate that goes on here covers up most of this. Plate installed, and you can see over here I had to Dremel out some space to accommodate the servo. It stuck out a little further than I wanted to, but overall you can barely see any of it from outside.